webinar, the 5 things that can go wrong with do-it-yourself disaster recovery. Your host today is going to be Mike Hamilton, and Mike Hamilton is nScale's Director of Client Services. So take it away, Mike.
Hi, everyone, and thanks for joining us today. Today we're going to be talking about the 5 things that can go wrong with do-it-yourself disaster recovery. So let's just kick off the slideshow here and get started. So we're going to cover 5 things today, obviously. That's why the list has the number 5 in it. Stand-to-stand replication, choosing the right remote co-location facility, failed testing, hardware and software drift, and underestimating the resource and skill set requirements of do-it-yourself disaster recovery. So when surveyed, people who have done disaster recovery on their own have the following list of things that say that it's a big headache for them. Backups take too long, recoveries take too long, dates are intensive, it's difficult to validate recoverability. You can see the graph. These are the basic trends that we see when we ask people. People are asked what is hard about disaster recovery and doing it on your own. But we're actually going to bring a different take to this in that we have a lot of experience working, first of all, being experts in disaster recovery ourselves. Second of all, having access to prospects and customers who have done this themselves or planning to do it themselves or have done it and had no success and are now looking just for some help to do that. I'm going to bring you up to speed on the things that we've noticed that cause people the most difficulty and the most complexity in getting a do-it-yourself disaster recovery solution put together. So really we're going to be covering the things that you want to watch out for if you're planning on doing it yourself. If you're going through the process right now of planning and allocating resources, allocating budget, these are the things you want to look at. And I'm going to start with stand-to-stand replication. The reason I'm starting there is because all too often it's really easy to think that the hardest part of do-it-yourself disaster recovery is getting your zeros and ones from site A to site B. So getting all your bits from one site to another. It seems like that would be the hardest part, and the SAN vendors are all touting their capability to do this, as a part of their feature set. Obviously, it works out really well for SAN vendors because they sell 2 of everything instead of 1. But there's actually more to it than that. It's not just a matter of buying 2 SANs. It's not just a matter of buying the software licenses. There's actually some things you have to consider with the SAN and with the SAN architecture in order to do disaster recovery yourself using that technology. So the first one is that you have to look at how your virtual machines are laid out. So essentially, let's say that you have all of your virtual machines on one big volume, and you're presenting those to your ESX servers. Let's say it's an NFS volume or iSCSI, however you plan to do that. The reality is you have to snapshot that entire volume at the same time. In other words, if you have 100 virtual machines or 30 virtual machines, whatever your number is that you're planning on putting on these volumes, and you're thinking, okay, I'm just going to snapshot that whole thing and get it all off-site and replicate it all off-site, and then I have everything. The reality is that if there were, say, 10 VMs that you didn't want recovery for, you still have to take a snapshot of those because they're on the same volume, and you have to snap the whole volume. Another consideration is the application-specific agents, so I'll go into a little bit more in the next slide. Snapshot storage requirements are something that also tends not to get talked about too much, and that is that your snapshots take up space, and where that space comes from varies from SAN vendor to SAN vendor. So some SAN vendors require that the space be in the same storage pool as the volume that you're protecting in the first place. In other words, if you had a 40 terabyte SAN and you had a pool of 20 terabytes dedicated to one set of resources, then with some SAN vendors, you actually have to snap that 20 terabyte volume in the same 20 terabytes. You can't extend over into the other 20 terabytes that you got allocated for something else because it has to be part of the same storage group. So it's a really important planning consideration and question to ask your SAN vendor, where does my snapshot have to come from? Where does the space get used? Because it's obviously going to take up more space for you because you're using the same appliance. And one of the things to think about also is how much is that snapshot space actually costing you? With our solution, we actually take snapshots off to a low-cost appliance that keeps your snapshot cost and the storage cost low for retaining snapshots of your servers. If you're using really expensive storage and you're keeping the snapshot stored on the same storage unit, that can get expensive really quickly because of the amount of storage required. So the snapshot agent part of it is really important to understand because in terms of stand-to-stand replication, the way that you can actually take application layer snapshots is usually going to require you to change the way that you're using your server. So I'm going to use a database server as an example. And let's say that you're starting with a database server right now that has the operating system, the database, and the logs all in the same box, or all pointing to the same place, essentially. They're all VMDKs, they're all direct attached storage, but they're all essentially on the same location. And let's say that you're planning on using disaster recovery with SAN-to-SAN based replication, and you're going to use the SQL snapshot agent so that you can get SQL-based recovery from the vendor. The only way that a vendor can take a SQL or Exchange snapshot is if they have the LUN that the data is stored on directly presented to the host. In other words, if it's a Microsoft SQL server, you actually have to present the storage directly to the SQL server from the SAN, and the agent has to go on the SQL server. So the vendor's agent has to sit on the SQL server. The data has to be directly presented from the SAN in order for the SAN to tell the operating system, hey, I need to take a snapshot. It's a design consideration that you need to take into account when you're planning it, because what it means is that however you're set up now, don't assume that that's going to work for planning disaster recovery if you're going to use SAN-to-SAN replication. You may have to change your environment. You may have to think about how you're doing things, and there's labor associated with it. There's planning associated with it. And so it's easy to get caught up in the simplicity of how cool SAN-to-SAN replication technology is and then miss out on the architectural considerations. The next problem with yourself disaster recovery has to do with location. You know, and if you know anybody in real estate, location is the most important thing, right? So let me frame the challenge for you really quickly. So let's say that you're a company with a single main office, or even if you have multiple offices, let's say that your IT resources, your data center, is all coming out of one central office, and you're picking a DR site, and you're going to do disaster recovery yourself. What we've found in asking prospects as well as customers who have done do-it-yourself DR is that they have a tendency to pick a location that is too close to their existing location. And the reason that they pick it is because their same staff who does their day-to-day IT operations ultimately ends up being the same staff that's going to perform the disaster recovery. Now the problem with this is that all too often, while that seems like a convenient consideration, it's the wrong approach. And the first thing to take into account is what kind of disaster are you protecting yourself from? If, for example, it's a large geographic disaster like a hurricane or an earthquake or a flood, these kind of considerations, you know, will you be able, they're going to affect that. For example, the data center may be under the same exact risk as your production data center. So if your DR site's in the same risk zone as your production site, that's not going to work particularly well. The second problem is that in the event that for some reason the DR site is actually working, will your staff actually be able to get there? So maybe the DR site's fine, it's fully functional, but because of the nature of the disaster, your people actually can't get to it. And we'll talk a little bit more about how to plan resources and what goes wrong with planning resources around disaster recovery. But choosing a location can be really tricky. It needs to be far enough away from your current production location where it's not a part of the disaster risk zone, but then close enough typically to where you can get there if you need to. It's very challenging and it's hard to do. It's especially hard to do effectively, given the choices that most people have to choose from in terms of disaster recovery locations that are available to them. Now, this is one of the hardest ones to nail down because it actually changes from environment to environment. But the third risk to success in do-it-yourself disaster recovery is hardware and software drift. And what I mean is, your production data center and your disaster recovery data center have to be kept in some kind of sync with versions. This can go all the way down to the router firmware, the switch firmware, but it can also go all the way up into the hypervisor version, the operating system version, the application version. And it's really important, and what gets lost a lot of the time is how do we keep up the disaster recovery site with our production environment? In my experience, for example, a lot of people say, you know what we'll do is we'll use our DR site for upgrade testing as well. Like, so for that key accounting application that we have for our company, we'll use the DR site to test the upgrade first, and then we're going to go ahead and do the upgrade in our production environment. But then, while the best laid plans look great on paper, a lot of the times what ends up happening is there's some kind of urgency that makes them do the work on production. And either way, whether you upgrade on the DR site first or the production site first, you have some period of disparity. You have some period where they're not in the same place. And I want to raise another potential issue as well that you want to consider. A lot of people that I talk to, I know this is a strategy that I had used in the past as well, they'll say, you know what we'll do is to build the DR site instead of buying all new equipment, because that's going to be really expensive, we'll wait until we've gotten a significant enough ROI on the equipment we already have. It's hit the end of its warranty. Maybe we buy an extended warranty, maybe we don't. But the bottom line is that as we're refreshing our hardware, we'll just move the old hardware into the DR site. This seems like a really simple solution, an obvious solution, but again, it doesn't cover how do you keep the versions in sync with each other. Although it does save money, it can cause problems. For example, if the virtual machines are built under a certain version in your production environment and you don't have a similar chipset support on the processor in your DR environment, the hypervisor can give you issues because now all of a sudden maybe you don't have everything exactly in sync. There's a lot of considerations to take into account. So saving money by reusing existing hardware doesn't necessarily get you out of any more work. It gets you out of some cost, but the bottom line is that there is drift. There's going to be some kind of a difference between your DR site and your production site. And if you think about it, if you were to ask your IT staff today, how much time do you actually have to spend on maintenance on our production site? Forgetting the DR site entirely for a moment, do you have enough time to really maintain it? Who's checking the logs? Who's keeping up on the patch levels? Who's making sure that the firmware updates are going to work? Who's making sure the operating system patches are going to work? If you ask a lot of them are going to tell you, we barely keep up with the production side as it is. So it's really important to consider that the disaster recovery site is another sort of care and feeding kind of a situation. It's almost like having another kid in the family where you've got this other mouth to feed, you've got something else to maintain, and if your IT staff can't maintain what they already have, it's going to be very difficult to maintain another site. And it's totally wrong to consider that you don't need to maintain that other site. Now here comes probably the biggest point of all, and this is point number 4, which is failed testing. And this is actually one of the things that we've had several customers come to us and say, you know what, we did do yourself DR, we had testing issues, and now we need help. And we need somebody to we need a service really is what we need. Why is this a problem? Why is testing so difficult? Well, for starters, you have to design the testing scenario yourself. So is it going to be a case where your production systems have to come down to do testing? And there's so many things to consider with testing that, you know, taking your production system down obviously ruins your uptime. It ruins your service level agreement with your users. So planning your actual test environment, your test execution is really critical. And then what do you do when your test doesn't work? Did you have enough resources for it to fail? This is a hard question for most people to answer because the assumption is it's not going to fail. It'll work. We've got the DR site set up. We've done everything. We've crossed our T's and dotted our I's. Our test is not going to fail. But the problem is that you have to plan for what if it does fail. If the DR test doesn't work, how are you going to overcome that? And what costs are associated with it, both from the standpoint of resources and from the standpoint of actually cost. The biggest reasons why testing fails is, and it's in quotes on the top line there, we didn't know what we didn't know. We didn't know that this application had some specific configuration that only works in its current implementation, and when you move it out of there, you have to change 5 things. Again, you'll figure this out on your first pass probably, maybe, when you do your first test, but how much time did you lose figuring that out, just getting the test environment to work for yourself? Application requirements can be lost over time. For example, the person who originally set it up, the first person who ever installed it, probably remembered at the time the 10 different considerations that he went through while he was working on it or she was working on it, only later to realize that like nobody documented any of that. And so now the DR site, we're discovering like, oh man, what was that setting supposed to be? Or oh my gosh, that requires a license server. You know, there's all these different considerations that come up as a part of testing that you didn't have time for. There just wasn't enough time allocated for it. I like bullet point 3 the most. A big reason for failure is an oversimplified assessment of the problem. And where you'll tend to see this is if you hear the following phrase in a meeting. So somebody says, for example, how do we address A? And one of your people says, hey, all we have to do is ... The phrase, all we have to do is, almost always represents some kind of oversimplification of something. This is like 15 years of my IT experience talking here. And I'm sure that like those of you in the audience can probably attest to this. that in the past when you've heard somebody say, all we have to do is, you find out later that like it wasn't actually that simple, and they had it worked out pretty well in their head. The fact of the matter is you probably employ some really smart people, and I'm sure they're smart enough to do disaster recovery, but how much time do they have to really dedicate a thought process to it? They might be thinking to themselves, like, I know, all we have to do is, and they've got it figured out, like over the, the next few days they'll plan it out and they'll map it out in their head, and they might even document something, and then something else comes up, because realistically the top priority of every IT department is the demands of the users. And the bottom line is that IT staff ends up dealing with those top priorities first before they end up dealing with anything else. Looking at the sort of layered stack over there, you can see that these are all considerations, that it's a layered approach. I came up with an example the other day. Suppose what you wanted to test was whether or not the light bulb in your refrigerator actually goes off when you close the door. Well, you might stick, for example, a wireless camera on the inside to verify that the light goes off, and that would be a visual test. You might put some kind of voltmeter on the circuit that puts the light bulb on to see if the light bulb actually does click on, when the door closes, and then click on when the door is open, click off when the door closes. Those are all tests for the same thing. But that's only one layer. You're trying to prove one thing. Did the light bulb go off when I closed the door? With disaster recovery, you're not testing one thing. You're testing multiple layers. There's the infrastructure. There's the hypervisor. There's the operating system. There's this underlying SAN. There's the underlying network topology. There's the NAT. There's the firewall. There's the routing. There's the logs. There's tons of things to consider when we're dealing with this kind of testing. Going back again to bullet point 4, if your team right now can't monitor or keep up with the monitoring and log tracking of your current environment, how are they going to keep up with the disaster recovery environment? How are they going to know, for example, the SAN-to-SAN replication is working perfectly? How are they going to know that that data has the right level of integrity and that it's going to work in a disaster without testing? And then when you do get to testing, do you have the resources for testing to fail? Now this one is huge. So I'm going to break this out into 2 scenarios. One scenario is that you're a company who has one site and one set of skills. All of your skilled people are in one location. And then scenario 2 is you're a multi-site organization and your skill set is spread out across multiple sites. And I'm going to take case B first. So in case B, you've got skilled people all in other places, and you've designed your disaster recovery strategy to account for the fact that people in other places could get to the DR site and actually do some work in the event of a failure. If you have people at other sites, do you have the right skill set at the other sites? So for example, if the DR site has a networking problem, is there somebody at one of your other locations that can take care of that problem? And the underlying theme here is you can't assume that the guy with the routing skill set, for example, is going to be available in the event of a failure. So there's a certain amount of risk. It's almost like betting on horses almost, really, because if your skill sets are spread out across multiple people, how do you know which event is going to take out which resource and what issues you're going to have on the DR site? Now let's say also that you're just a single site and all of your people are in the same location. Again, the same problem presents itself. If all of your people are in one place and the skill sets required are all coming from one place, will they be able to get to the DR site and do work? If it's a massive power failure, for example, or whatever the disaster was, took out the power grid and therefore the internet service is down, can your people actually get into the DR environment to do the work that they need to do? In a disaster, depending on the scale of the disaster, even if it's a power outage, people are going to take care of their needs first. Is my family okay? Am I safe? Then they take care of the company later. One of the ways that you can deal with this, and I highly recommend it actually, is to have consultants on retainer. So if you've got one routing guy and he's a single point of failure, that you have some kind of consultant that you keep on retainer just in case. It's a good cost to consider for disaster recovery. We have a customer, for example, with some very specific exchange requirements, and they keep a consultant on retainer who's out of the area in case something happens. And this customer did actually have a disaster and did call on the consultant to do the work. So it's important to have that. Look at where your skill sets are, look at what the redundancies you need are, and factor in the costs of what it will take to keep somebody on retainer. Just to cover yourself in the case that you actually need somebody to step in. So those are the 5 things that I want to talk about, the 5 things to watch for do-it-yourself disaster recovery. Now I want to talk about what our advantages are. And this is going to be a very quick piece of it. It's just one slide. But given everything that we've talked about, what are nScaled advantages? Why would you want to talk to nScaled about doing disaster recovery? For starters, we have a SAN-agnostic server protection model. So regardless of what your underlying SAN technology is, we can protect your servers and replicate them off-site. And we do that to low-cost storage on an appliance that we provide you with. The benefit here being that you don't have to expend your expensive SAN resources to protect yourself in the event of a disaster. The DR infrastructure is maintained by nScaled, so all of the infrastructure required to function in a disaster is maintained by us. We're taking care of the firmware. We're taking care of the underlying hardware that you need to run in the event of a disaster. We're maintaining that site for you. We're presenting you with key metrics that you need to monitor, and those metrics are delivered with alerting. In other words, if I have a server that has had replication fail, in your environment, if you're doing it yourself, you have to figure out how you're going to make sure that that monitoring is done effectively. With nScaled, it's all presented in one SaaS cloud console. We provide you with a robust test environment. This is one of the most key components of our solution. You can test DR during the day, during production hours, without taking production systems offline. We provide you with an environment that allows you to activate your key servers in an isolated environment, run tests on them, see how they interact with each other, see how they interact with Active Directory, develop any documentation that you need, and even bring in the key application owners to make sure that it's tested and that it really would work. You can set up the NAT entries, the firewall rules, everything you need in the test environment, verify that it's going to work so that you know when you activate in production it's going to work for you. Our environment is supported. In other words, instead of trying to come up with all of the intermediate steps, all of the intermediate technologies to work for you, we've done that. We've gone through all of the work and we support it. We have a SaaS recovery console that's available from anywhere in the world. So obviously your staff's first priority is to get off-site, to get someplace safe in the event of a disaster. If there's internet access, even if it's from like an iPad with 3G, you're going to be able to activate your servers. And the beauty of our solution also is that it doesn't take an IT person to activate them. You can actually be, just a regular person and still activate a server in a disaster. It's very well done. And the last bit is that you have a choice of recovery sites. So we have multiple data centers in the US and the UK. Whichever data center you want your data to go into, that's where it goes. We don't move it unless you ask us to move it. But other than that, you can know, so you can pick your disaster recovery location. Right now in the US, we have Ashburn and Dallas. And Ashburn's in Virginia, Dallas is in Texas. And so this gives you a couple of sites. We're bringing other sites online as we see demand for them, but it gives you a choice rather than being limited to choices based on how far your IT staff can go or what's available in your neighborhood. We can give you different choices. In conclusion, I hope that I've given you 5 things to look for, 5 things to consider if you're planning on doing do-it-yourself disaster recovery. I think the most important thing to take away from this is that most companies want their IT staff to focus on their users, and disaster recovery is a massive project. It's a massive project that requires a lot of resources, it requires a lot of planning, and quite frankly, it's difficult to plan because there's a lot of unexpected capital expenses that will come up over the course of executing on it. So with nScaled, you get predictable costs, and it's backed by a support contract, it's backed by SLAs, and you get a cloud console. You can actually get started with us. We have a free account that you can set up, and it'll give you access to the cloud console, let you look around, see if it's going to meet your needs, get a feel for what the cloud console looks like, as well as it'll start engaging you with some of our great engineers. And thank you for attending today. Sarah?
Great, Mike. Thank you. That was wonderful. If anybody has any questions, please go ahead and type them into the question window right now. And we have a few minutes left, so Mike will be able to answer those questions for you. I also wanted to let you know that we did record this webinar, so I'll be sending out a copy to everyone after the webinar is over. Okay, and let's see, I've got the first question. Someone wants to know if nScaled has any data centers in the UK.
Yes, we do. We actually have a data center in London, and we're looking at a couple other potential data centers throughout Europe, but London is where our data center is there.
Great. Okay, are there any other questions? Give you just one more minute to type them in. And if you have questions after the recording, you can just email us at info@nscaled.com, and we'll be happy to answer any questions. Well, I guess we'll wrap it up. Again, thank you, Mike. That was great. And thanks to everybody for joining us.
Have a great day, everyone.